That's okay. I got things for you. I can take it. I can take it. Trig identities. Oh, wait a second. I need an autograph.
Oh.
Oh, sweet. Action. Right. My son's funny.
Yeah. I missed that.
You would probably strike me out, so that's okay.
Who's the Daily Chronicle sports photographer? They always get the most awkward angles.
If my dad was... Where's the N?
Yeah, there's no N.
More
It's just a line. Morgo. It's just a line. Yeah, I'll fix it just for you. It's Morgo.
You know, we had.
Oh, that's word.
We had. She was under pressure.
Morgay.
She forgot how to spell her name because she was. That's how awesome she is.
Your last name is can I just
Morgan.
No, it's okay.
Morgan, now it's a capital A for the N.
Anyway, identities. You guys know these 5 identities. You guys already know that cosecant is 1 over sine. You know that secant is 1 over cosine. They're the inverses. You know that cotangent is the inverse of tangent. One of the things that I'm going to tell you right now, because everybody keeps asking the same question, before you go on and write anything else down, just look at me for a minute, put your pencils down. I want everybody to make sure that you understand this. These guys all have cosecant of theta, cosecant of x, sine of x, whatever. They're going to put variables for the angles in there. I don't. Too many letters, it gets messy. I just shortcut it and just write cosecant is 1 over sine. It is implied that there's an angle there, okay? For all of these problems, they're going to write it out with some value of x, some theta. I just don't write it down. I never have. I probably never will. The only reason why I do that is because it just gets to be so many letters, it gets really messy with some of these problems. And as we get into this a little bit further, you'll kind of see what I mean by that. I just wanted you guys all to understand that before I go too far, because everybody else, I've asked that question, where's the x? What happened to x? A lot of times today, so. Anyway, you guys remembered that tangent was sine over cosine. That came from the unit circle, x over y. Somebody waved to Willis, so he walks away.
Will.
Cotangent was the inverse of that. These 5 trig identities were not new to you at all. We talked about all of these back in chapter 13. This was all built off of the unit circle. Okay? The new ones come from the unit circle. And it basically comes from one single property. I'm going to go to a fresh, I got them up on the board there, so I'm just going to go to a fresh one here. If I take a circle, oops, and we call this, we'll just make this our unit circle. If I do that, do we all agree that this point here is some value x, some value y?
Yeah.
We all agree on that? When I redraw that, what's formed at the base? 90-degree angle. This is the value of x, this is the value of y. Does everybody agree? What is that?
R.
It's r. In our unit circle, what was r always equal to? 1, right? Remember how we always used the radius of the unit circle was 1? Remember we went through the quadrantals, it was always 1, 1, negative 1, negative 1, so the radius was always 1. So if I wanted to figure out, I could write this as x squared plus y squared is 1. Do you agree? What did x and y stand for in the unit circle? Cosine and sine. This was cosine, and this was sine, right? So is this the same thing as saying cosine squared plus sine squared is 1? That's a trig identity. That's the sixth identity. It's built off of the unit circle with the Pythagorean theorem. This is a Pythagorean trig ID. They don't write it usually as cosine squared plus sine squared. They normally write it as sine squared plus cosine squared is 1. All right? It doesn't. What's 2 plus 3?
5.
What's 3 plus 2?
5.
It really doesn't matter. Now, one thing I will ask you is, Kayla, if I wanted to get sine squared by itself, what would I have to move? So what would sine squared be equal to? Yeah, it'd be 1 minus cosine. And you're saying negative cosine plus 1. You can move sine squared and cosine squared and solve for each one of them independently. You're not going to have to worry about taking square roots or anything like that, but you could say that sine squared is 1 minus cosine squared. You could say cosine squared is 1 minus sine squared, just by manipulating that equation. Everybody okay with that? Now, let's use this sine squared plus cosine squared equals 1. Let's use this Pythagorean identity to derive the other two. We can always remember this one. It's very easy. Sine squared plus cosine squared is 1. Straightforward. It's Pythagorean theorem. X squared plus y squared is r squared. When you work with an equation, if you do something to one side, what do you have to do to the other? Same thing. So if I divide everything by sine squared, is that a true statement? That I divided everything on the right by sine squared and everything on the left? Yes. Yeah. So what's sine squared divided by sine squared? 1. It's the same thing on top and bottom, right? What do you think cosine squared over sine squared is going to equal? What is it? Is it tangent or is it going to be cotangent? Cotangent. Is it going to be squared or not squared?
Not squared.
It's going to be squared. What I'm doing here is cosine over sine is cotangent. Cosine squared over sine squared would be cotangent squared.
Equals cos.
Equals 1 over sine squared is
Cosecant squared.
cosecant squared. That's the next Pythagorean trigonometric identity. Again, what I'm doing here is I'm starting with the very basic sine squared plus cosine squared is 1. I divide everything by sine squared and I get 1 plus cotangent squared is cosecant squared. Which means if I wanted to get cotangent by itself, what would I have to do to the 1? I would just subtract it over, and I would get cotangent squared is cosecant squared minus 1. I can manipulate these things to move them back and forth to solve them independently. Now, if I do the same basic idea, and I start with my sine squared, cosine squared is 1, and if I divide both sides now by cosine squared, I still have a balanced equation because I'm dividing the same thing on both sides. I wind up with sine squared over cosine squared, which is tangent squared. Cosine squared over cosine squared is, and we have a secant squared. Again, what's happening here, guys, is that you're using that very easy sine squared plus cosine squared is 1 to manipulate that equation to get the other two identities. So if all you remember is this, isn't it pretty easy to make the other two? So do you really need to memorize the other two? As long as you know how to get the other two, you're gonna be fine. Because the basic 5, you already know. You knew cosecant was 1 over sine. You knew secant's 1 over cosine. You knew those. The one you didn't know was sine squared plus cosine squared, 1. So when it comes down to the test for this chapter, which will be next week sometime, what I would suggest is that you just write down sine squared plus cosine squared is 1. Take a second and just write out the other two off of it. Now, would it take nothing to memorize the other two? But if you forget it, it's very easy to make up the other two. That gives us the, what is this, 7 of them? Tangent squared plus 1 is secant squared. 8 of them, sorry, there's 8 of them. Now, what is all this going to allow us to be able to do? It's going to be able to, we're going to be able to do these. Simplify. Cotangent times secant. How can I simplify it? You see what I'm saying by putting all those values of x there? It just gets messy. I'm going to simplify that. Think of this as a monomial with all those exponent rules that you have to try and rewrite and simplify things out. This is what you're looking at doing. You're going to take that cotangent and rewrite it. Yes, sir? You're not cross multiplying because there's no equal sign. You're looking at simplifying. You're on the right track though. I know what you're getting at. So how can I rewrite cotangent? Cotangent is what over what?
Cosine over sine.
Okay. So you get cosine, bless you. Secant's what?
The 1 over cosine. So we just cancel.
What this is what you're talking about by canceling out. What drops out? 1 over sine is the same thing as cosecant. You just simplified it. By rewriting it, all these inverses, all the cotangents, tangents, secants, whatever, if you can rewrite everything in terms of sines and cosines with this multiplication, you're going to find out real quick that you can do things like that. You'll be able to simplify out. It works really nice when you just have cotangent and secant when nothing is squared. The moment you start seeing stuff that's squared, you might want to start thinking, do I need to use one of the trig identities? Do I have one of the Pythagorean identities to work with? Like in the next example, sine times 1 plus cotangent squared. Well, what's 1 plus cotangent squared? Cosecant squared. What you're being able to do here, well, let me show you this. Let me ask you this before we get too far here. Does everybody agree that you could do this? Distribute? We'll go both ways. What is 1 plus cotangent squared, according to the identities that we know now? Cosecant squared. So this is the same thing as saying sine times cosecant squared. What's cosecant squared in terms of sines? What's that?
1 over sine squared.
Yeah. What drops? One of the sines. Sine squared means sine times sine. Everybody agree with that? Think about it in terms of just x over x squared. What's 1 over sine? You get a cosecant. Now, do you see what I mean? That this is kind of like a geometric proof, in fact, that you're using identities to get to a simplified answer. You just don't know what the answer is going to be yet. Now, on the other side, if you distributed, you'd wind up with sine plus sine times cosine squared over sine squared. Are you okay with that? How you simplified it out that way? Then I get a sine. What's that? I rewrote cotangent squared as cosine squared over sine squared. Now I'm left with that. Gross. What do you have to do if you have fractions when you're adding? Common denominator. So it starts to get really messy really fast, right? Here's a hint. If it starts getting messy really, really, really fast, that means there's probably another way to do it. You could go ahead and continue, but if you start to see that coming up like this, there's an easier way. Stop, start over. Okay? That's a little bit of a hint. We will start with these types of problems. I'm not going to finish that one because it gets really messy. We're going to start these problems out today very simplistic. We will build them into the ones that are a little bit nastier. And I'll show you a couple of those examples a little bit later on. Okay? It also allows us to do this.
Build time.
Sine of b over the tangent of b is it is really bad, but it's funny. It's math humor. Here's what happens. I'll use the letter b here. Sine of b over the tangent of b. When you have a fraction like that, tangent can be rewritten as what? Okay. So this is the same thing saying sine of b divided by sine b over cosine b. All I did is rewrote that horizontal. Everybody okay with that? When you're dividing fractions, what are you doing? So if you multiply by the reciprocal, here's your sine of b times cosine of b over the sine of b. And hence why math humor is funny. You get cos b.
Do you know him?
We're like brothers.
Does he like you?
No.
You should really ask.
I should ask. No, but I do want to borrow one from Mr. Tiggs.
Is that Mr. Rogers?
Or Mr.
Is that Aaron Rodgers? Aaron Rodgers was in Wisconsin.
What's different now? What's different now from the examples we just did?
We already have the answer.
There's an equals. We have an answer. We're not solving an equation here.
We're figuring out why it's 1.
Exactly. Hey guys, this is as close to the geometric proof as what you're going to get. Notice that there's an equal sign. It's telling you that this is going to simplify to equal 1. Your job is to show how it does that. That's the exact same scenario as every geometry proof you ever did. You were started with a given, and you had a prove statement. Your given is cosine times secant. Your proved equals 1. Your job, show it, just like you did in geometry last year. You guys had those two parameters. You used your given statements. You used theorems and proofs and what. No, this isn't going to be 2 column. This is more of an algebraic style. What you're doing here is that I always thought that verify was easier than simplify because I know what the answer has to be in the end. It helps lead me to it a little bit better. Then the simplify, just kind of going, oh, I might get it right. So when we go to these things, cosine and secant, they're inverses of one another, aren't they? So secant can be rewritten as what? So all you do is this, cosine times 1 over cosine, dun dun dun, equals 1. And it's verified.
Wow. So you're pretty much just showing your work.
Exactly. That's exactly what you're doing. Now, not all verified problems are going to be that clean. There will be ones that are going to be nasty, and I'm going to eventually get you there. When I go to the next one, notice how we have tangent, cosecant, and cosine. I have nothing written out in terms of being squared at all, but I can rewrite all of those in terms of sines and cosines. Tangent is what? Excuse me, what over what? All right. So I get sine over cosine. Cosecant is what over what? 1 over sine. And then I have just plain old cosine. Dun dun dun.
Can't you do it another way too? Using the tan cotangent?
You can if you want. You can do that if you wanted to rewrite it as 1 over cotangent. Then you'll wind up with a complex fraction.
Well, no,
It will work.
well, cosecant times cosine, shouldn't that be cotangent, which is just 1 over tan?
Yeah. Oh, yeah. I see what you're saying. Yes, you can do it that way too. What Dylan's asking out here, guys, there's more than one way to do these. What he saw right here was 1 over sine times the cosine gives him cotangent. And then he had a tangent over here. Tangent times cotangent, well, that winds up being the inverses of one another. So you have tangent times 1 over tangent, and you still get 1. There's going to be more than one way to do this, usually. Yes, sir?
Will the things on the other side ever not equal 1?
Yes.
And thus it will be wrong? Like
No.
this- no, like the statement itself is wrong?
No, I don't think I'm going to give you anything like that. I'm not going to have you prove a false positive, or if that's what I'm thinking.
Yeah.
It is. No, your verify will equal something. And I've got other ones that don't equal 1. I just wanted to show you how to start out with. I mean, for example, this one doesn't equal 1. This one doesn't equal 1.
Oh, God.
Yes. That's just things that are more So here we have cotangent squared over cosecant, and I have to show that it's going to equal cosecant minus sine. So one of the tricks that you're going to see is that notice how it goes from division and then all of a sudden it branches off into a subtraction problem? The only way that you're going to be able to do that is if you wind up using one of the Pythagorean identities. Because the Pythagorean identities have a plus sign in it, a minus sign. You can move things back and forth. So what I want you to do is to start thinking in those values. What can I rewrite cotangent squared as? I could do that, but I want to talk about Pythagorean identity. I'm looking at the three-part ones. Which one?
Cosecant squared minus 1.
What's that?
Cosecant squared minus 1.
Yeah.
Good. What I can do here is if I use 1 plus cotangent squared is cosecant squared, if I get cotangent squared by itself, all I gotta do is subtract the 1. Everybody agree?
Yeah.
So what I'm doing is I'm using those Pythagorean identities to say that cosecant squared minus 1 is cotangent squared. This is still being divided by cosecant. Everybody okay with that? Now, think about rules of fractions. What can you do with that? Is the 2 the common denominator for both the x and the 4? Because couldn't you do this?
Actually, 2 minus 2.
Couldn't you do that? Basically. This happens quite often with these trig identities. If you have a single value in the denominator, 2 parts up top, rewrite it as 2 separate fractions. Because now, what's cosecant squared over cosecant? Think of it as x. It's just cosecant. Think of it as x squared over x. Just becomes x. Here you just get cosecant. And what's 1 over cosecant? And you verify. Again, what I've done here is I took the common denominator and I wrote it twice. I split it among both fractions, both parts. I turned it into 2 separate fractions. Cosecant squared over cosecant is along the same lines as x squared over x, gives me just the value x. In this case, cosecant. 1 over cosecant is sine. I verified it. cotangent squared divided by cosecant is cosecant squared minus sine squared. Again, when you see that you're starting with division or if you're starting with multiplication and you're ending up with a problem that has a subtraction or some addition into it, that means you're going to have to work with common denominators with fractions to be able to do that. More often than not, you're probably going to use a trig identity, one of the Pythagorean trigonometric identities, to make it work. Okay? Let me show you another one. There's another twist. Believe it or not, you're going to use the same principle for solving this as you did when you did a problem that looked like this. I'll let you write that out first. I'll come back to that. One of the properties that we dealt with way back when we first started working with radicals is that we all agreed that you couldn't have a radical in the denominator. We had to rationalize. Remember that? You had to multiply to get rid of it. When you had 1 plus a radical, we had to multiply by subtraction. We had to multiply it by something else. It was called the conjugate. What would the conjugate be of 1 plus root 3? What's that?
Yes.
Yo capito.
It's a math.
Lo siento. Qué bueno para su clase de español. Es muy importante para su educación. Cállate. What would be the conjugate of 1 plus root 3? 1 minus root 3.
Oh, that's good.
You would multiply by 1 minus root 3 to the top and bottom. Because when you FOILed that out, the radical went away, the middle term would drop out. Vaguely remember a little bit of that?
Oh, with the I.
We did that with eyes a lot, yes. We basically will do the same scenario with the trig stuff here. So if I have sine over 1 minus cosine, what would the conjugate be of 1 minus cosine? 1 plus cosine. Now this looks really weird, but what is 1 plus cosine divided by 1 plus cosine? It's 1. Again, what I'm doing here is I'm multiplying it by some factor of 1 to change its shape to make it something easier to work with. So I have to FOIL the denominator. First, outside, inside, last. Everybody okay with that? 1 plus cosine minus cosine squared. What happens to those middle terms? They drop out. What you're doing here by multiplying by the conjugate with trig functions is you're creating one of the Pythagorean identities. So your new denominator becomes 1 minus cosine squared. The numerator was sine times 1 plus cosine. What's another word for another form of 1 minus cosine squared then? What are you pointing at? So what is 1 minus cosine squared? Sine squared. What happens?
1 sine drop.
One of the signs drop out. So you wind up with 1 plus cosine over sine.
Yes.
Again, what you're doing here is you're going about using a conjugate to develop and create one of the Pythagorean identities. And it just winds up simplifying out after a little bit of work. Like I said, You're not gonna like this, you're gonna get mad at me, I can take it, okay? It's really a matter of just getting accustomed to seeing how these things work. Try one on your own. This is a simplify. This is a simplify. This is not a verify. This is a simplify. Try it, see how we do.
Happy birthday, Caleb.
Did you guys FOIL the numerator?
I could tell. Yeah.
When you FOILed the numerator, did you get secant squared
You're older.
minus 1 over tangent? According to the Pythagorean trigonometric identity, what's secant squared minus 1? Tangent squared.
Let's get it, baby. Cubs, just one, two.
And you get tangent. Did it?
Yeah.
Oh, expanded replay.
Oh, I
for
still
the
have
first
no-
time in MLB.
Wow.
Especially Marja out
I
at
still
the
have
base.
Let me show you what we're going to be doing eventually with these.
That, we use like those other ones.
Oh,
I know, right here says tangent squared plus 1 equals secant squared. So Q minus 1. Tangent squared equals secant squared minus 1. And then the other guy. Still 0-0, Murph.
Put it away.
I have,
Yeah, we will.
Pittsburgh.
Not like right now, do you?
I'm going to walk you through it. This is some of the more of the complex stuff that we're heading towards tomorrow. But I want to show you the same basic process, but it's getting more complex.
Is that a cross or a?
It is cotangent plus tangent, and it's going to equal cosecant times secant. So here's what I have. Here's what I want to look at. Is any of this stuff squared?
No.
No. None of it's squared, which means I'm not going to be using a Pythagorean identity, probably. But cotangent and tangent, they both can be rewritten as fractions. Do you agree? So if I rewrite them as fractions, I would get cosine over sine plus sine over cosine. Does everybody agree with that? Yeah.
How do you know when you want to use 1 over 10 or cos over
You notice what you're telling me. See how you're trying to verify that it's cosecant and secant?
10? Yeah.
Is it cosecant and secant one
But
over
it'll be
cosine?
pretty easy to like figure like which, because isn't tangent or isn't cotangent also 1 over tangent?
It is.
So you just gotta feel it out.
Yeah, and it's one of those things. My suggestion is more often than not when you're working with cotangent and tangent is to usually write them as sines and cosines. It doesn't always work to do it that way, but more often than not, it's not a bad first start. Okay. Does everybody agree that this is just fraction plus fraction? Okay. What would you do if it was this?
Multiply them down.
You get the common denominator. What would the common denominator be for a 2 and a 3? How did you get that?
2 times a lot.
You multiply them together. What would the common denominator be for a sine and cosine? Sine times cosine.
There's no term for sine times.
There is, just called sine times cosine.
But it doesn't get its own thing like sine divided by cosine does.
No.
Sine cos.
So my common denominator in this case would be sine times cosine. Everybody okay with that? Now, fraction on the left, if I'm working with common denominator, what is this one missing? This side's missing a cosine, isn't it?
Yeah.
So what's cosine times cosine?
Cos squared.
What's this fraction missing on the right? What's sine times sine? What's cosine squared plus sine squared?
1.
It's 1.
Oh, we know that.
So then. Oh, and then you could break them apart.
And isn't 1 over sine times cosine? Isn't that the reciprocal of cosecant times secant? Notice you used the properties of the fractional amounts of cotangent and tangent. You used a common denominator, and we wound up with working again with the Pythagorean identity. There's going to be more than one way to set these things through. What we're going to be working on over the next couple of days are these style problems. Don't get overly frustrated to start with. To be honest with you, the more difficult stuff is tomorrow. You should be able to get through these problems really easy today. Yeah?
So are we gonna actually need our calculators?
No, you won't need your calculator for this stuff at all. We don't really need your calculator in this chapter really for anything.
In this book.
Where do I have it? Use it
Most
all
of them.
year.
You might as well throw out your calculator.
No homework.
Throw out your clothes.
Oh, here it is. All right, so this is section 14.3. It's page 853.
I'm nervous now. It made my heart rate.
I have 7 of these for you guys to do. We're skipping around on the problems themselves because there are other identities that I haven't shown you yet. I just wanted to start with the basic ones. We have what are called negative angles, and we will also have co-functional angles. I don't think we'll do the co-functional, but we'll do the negative angles at some point this week. Okay? We'll be done with this chapter middle of next week, so we'll try and test out of it then. April is kind of weird because we don't really have a lot of school. So, all right, questions? Suggestion, guys: put down these identities on your homework so you have them in front of you while you're doing them. It's not that bad. Brittany, I thought you had your hand up. I'm sorry. Did you have a question? All right. Glad I could help. Yes, sir. What do you got?
These
These. Shut this off.